BIV Day. This is one of my most favorite times of the year because guess what my name is? My name is Roy G. BIV. And my favorite thing to look at is light and color. And that's what you're going to be doing today. Now, before we start, I want to make sure that you guys know all your colors because my name is Roy G. BIV. And I want to make sure that you know what all those letters stand for. So I know you're at home, but when I say a letter, even though you're at home, you could yell out what color that letter stands for. Are you ready? R. Did I hear red? O. I think I heard orange. Y. I think I heard yellow. G. Yeah, I heard green. B. I heard blue. Now here's the hard one. I. Anyone know what I stands for? I stands for indigo. And V does not stand for purple, but you're close. V stands for violet, which is basically purple. So Roy G. BIV is all the colors in the rainbow, and that's what we're going to do today, experiments with color. And just because you're doing remote learning doesn't mean that you can't do science, because science is everywhere. So it doesn't matter if you're at school or you're at home, you can still do science. So what we're going to do is talk about color. And we're going to do a few little experiments with color. Now, first thing we're going to do is show you that color can give you clues when something's changing. Now, what do I mean by that? Well, sometimes scientists, they mix different colors of chemicals and liquids together, and they end up with a new color. Well, a new color means that something has changed. So let me show you guys what I mean. I've got this liquid here, and it's hard for you to probably see in the video, but it's like a really, really dark green. Now, I'm going to add something to that, and we'll be able to tell if some kind of chemical changes happen if it changes color. Now, this is vinegar. Some of you may have this at home if you've dyed Easter eggs. It kind of smells like pickles a little bit. So, does everyone make a prediction in your head about what you think is going to happen? Here we go. Whoa! Look at that. So it changed color. And because it changed color, that tells us that something has changed. It's made something new. So, I've got another liquid here. I'm going to pour that in. Let's see if something changes in here. If it changes, a lot of times it turns color. Okay, make a prediction in your head. What color do you think it might turn? Got your prediction ready? Here we go. Whoa, that's kind of dark, but it's like a, can you guys see that? It's like a really, 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 really dark purple. Now, here's the question. If I add this, do you think it will change back? Make a prediction. Here we go. I'm going to add some more of this. You ready? Whoa, it changed back. Now, you won't learn about this in kindergarten or first grade or even second grade. You probably learn about this when you're in middle school or high school. What we were adding was acids and bases. And acids and bases chemically change something. And we know something new has been made because we got a change in color. Kind of cool, huh? All right. So let me do another little demo for you. This one is kind of like the same thing. I've got a flower. And the flower is white. But I'm going to put on my safety glasses here because it's really important to always be safe if you're using chemicals. Plus, these glasses make me look good. So what I'm going to do is I'm going to take this flower and I'm going to spray this and we're going to see if something new is made. How will we know if there's been like a chemical change or something new made? Because it will change color. You ready? Whoa! Look at that. Do you think there was a change? There was a color change, so there's a good chance something new was made. And we're going to kind of do the same thing. We actually put something on that flower to make it change color. And I actually wrote a secret message on this piece of paper with the same material that I put on that flower. You ready? See that? Color and light rule. That's what Roy G. Biv Day is all about. So, we saw lots of new things being formed, and color was a clue that something new was made. Now, we're going to kind of switch gears and talk about light. Okay, light is kind of interesting because light is different than paint. If you mix all the colors of paint together, you kind of get this yucky brown color. But with light, if you mix all the colors of light together, you kind of get white light. I'm going to show you what I mean. And I'm going to have to turn off the lights. And hopefully I can do this without hitting something. So, you ready? I'm turning off the lights. Can you guys see that kind of whitish ball? Now here's the cool part. When I spin this around, it's going to turn into all the colors that make up white light, which is all the colors. Now, if you look at that, how many of you can see the red? Can you see green? Can you see blue? It's really hard to see, but how many of you can see kind of a yellow, orangish color? Maybe even a purple. So the cool thing about this is that with light, when you mix all the colors together, you get white light. And that's why rainbows form, which we're going to talk about later. When rainbows form, it's because the sunlight hits the raindrops, bends, and forms that Roy G. Biv, all the colors of the rainbow. Now, we're going to do an experiment that doesn't involve light. It involves mixing colors. And we're going to use Roy G. Biv's favorite candy. What we're going to use is Skittles. So what we did was we put all these Skittles very, 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 very neatly around this plate. And we're going to get a close-up of this. Our camera person is going to get a really, really good close-up of this. And could you pass me that hot pot of water? What we're going to do is we're going to put hot water onto these Skittles, and we are going to watch what happens. All right, now, I'm using super hot water. If you did this at home and you had your parents help you, they don't have to use super hot water. So what we're going to do is make sure these are all right up against the plate. And we're going to add some hot water. Now this is where you have to be patient. I'm going to take off my seat. But if you watch, you could start to see colors coming off of the Skittles. And it's really, really cool. So if you look, there's different colors coming off of each Skittle. And what makes this super cool is sometimes when two colors are next to each other, the colors mix. So like, I'm looking here, there's a green Skittle and there's a red Skittle. And if you kind of look in the middle, it's kind of brownish. And if there's an orange Skittle and a yellow Skittle in the middle of them, it's kind of yellowish orange. And you could see how all these colors are coming off the Skittles. Now, if you're really sciencey and you want to know why that's happening, I wish I could talk to you in person, but I can't. So Skittles have a lot of sugar in them. That's why everybody likes them so much. And when I put the hot water in, it dissolved the sugar. And that means that the color that was in the sugar dissolved too, and it all moved out towards the center. And it looks really, really cool. Now, if you do try this at home, you know what I would do? I would take a toothpick or even your finger if the water isn't too hot. And I would just slowly kind of mix it up and see what happens. See what happens to the different colors. Like, look what happens when you mix certain colors together. But this is our Skittles experiment where we mix colors together. Not light, but colors. Okay? Now, I'm going to let our photographer get one more cool picture of this. I really like that one, and that's an easy one to try at home. If you don't have Skittles and you have M&Ms, it'll work with M&Ms too, but I think Skittles work a little bit better. All right? Now, I've got one more experiment to show you what happens when you mix colors, and they call this one walking water. So what I did was I took these plastic cups and I put water in all of them. And in this cup, I put 5 drops of red food coloring, left this one blank. In this one, I put 5 drops of yellow food coloring, left this one blank. And in this one, I put 5 drops of blue food coloring and left this one blank. And then we put 5 drops of red food coloring. And then what we're going to do is we are going to let the water move through these paper towels. That's why they kind of call it walking water. But hopefully we know water doesn't have legs and it doesn't really walk. But the paper towels will soak up the water. So what we're going to do is put the red in the clear. So the red food coloring should move up and into this one. Then what we're going to do is put one from here into the yellow. And then we're going to put one from the yellow into the clear. And then we're going to put one from the clear into the blue. And then we're going to put one from the blue into the clear. And then we're going to put our last one into the clear, into the red. So, what do we got going? Here's what we got going. The red is going to move into here, and then the yellow is probably going to move a little bit into here. So the question is, we're not going to tell you, but what do you think is going to happen when you mix red and yellow? Then what will happen is the yellow is going to move into here, and the blue is going to move into here. So what color do you think we'll get when the yellow and the blue mix? And then here the blue is going to move into here, and the red is going to move into here. So what colors do you think we're going to get when the blue and the red mix? Now I know you're kind of looking at that thinking, not much is happening. And you're right, not much is happening now. But we have to let this one sit for around an hour or so. So what I'm going to do is sign off. Go take a little bit of a break, and we will be back in an hour, show you the results of an experiment, and then we're going to make a rainbow. So see you in a little bit. Hi everyone, I'm back, and we have our walking water experiment to look at. Now, I apologize because in the light it might be a little bit hard to see, but here's what we did. I'm going to cover this one up for a second. So in this cup we had red, and the red water kind of moved through the paper towel into this middle cup. And in this cup, we had yellow, and the paper towel and the yellow moved the paper towel over into this cup. So the middle cup is red and yellow mixed. What do you think that would make? Everyone have a guess? It makes orange. It's a little bit hard to see, but you could see it's kind of a combination of red and yellow. Then, in this cup we had yellow, which moved through this paper towel, and in this cup we had blue, which moved through this paper towel. So what do we think is a mixture of yellow and blue? Got your guess? Green. Yellow and blue, when you mix them together in colors, make green. And then one more cup to go. You've got the blue moving into this cup, the red moving into this middle cup, you've got blue and red. And this came out really, really dark. But if you look at a mixture of blue and red, got your guess? Blue and red make very dark purple. So if you look, this is sort of like a rainbow, only it's out of order. We've got red, well no, it's not out of order. We've got red, orange, yellow, green, blue, then kind of a purpley And then you got the red on the end, but that wouldn't be part of the rainbow. So you've got Roy, G, BIV, and then kind of indigo would go in the middle there. So these are the colors of a rainbow. Now this is mixing colors, it's not mixing light. When you mix all the colors of light, it kind of makes a whitish color, which is very odd. But when you mix colors, this is what you get. Now we've been talking about rainbows a lot. And it's hard to make a rainbow because usually rainbows are outside. And what two things do you need for a rainbow? You need sun, which we don't have in my basement, but we do have light. And you need rain. And hopefully it's not going to start raining in here, but we do have water. And what we're going to use to make our rainbow is this triangular thing called a prism. And what happens is, when the light hits the water, it'll bend. And if you want to get really fancy, you could say the light refracts. And when that light hits the water and bends, it'll separate the white light into all the colors of the rainbow. Because when you mix all the colors of light, it doesn't make colors like this. If you mix all the colors of light, it makes white. So we're going to take this white light, put it through some water, just like the sunlight would go through rain, and make a rainbow. Are you ready? Now, you're going to have to look for a rainbow. So I'm going to turn off the lights. So, lights are off, and I'm going to pour the water into this. And we've got light hitting water, and hopefully we will end up with a rainbow. You ready? When you see a rainbow, you can clap your hands. Oh, anybody see a rainbow yet? Hopefully you see that rainbow by now, and this is very cool because if you look, I'm coming over here, you could see all the colors that make up the rainbow. Red, orange, yellow, green, blue, indigo, violet. Roy G. BIV. And I love rainbows, and I love Roy G. BIV, and that's even my name, Roy G. BIV. So, hopefully you've learned a little bit about color, a little bit about light. Hopefully you've had some fun, hopefully you have some questions, and hopefully you have some ideas of things you can experiment with at home. So, this is Roy G. BIV wishing you all a great day, and have fun on this day. Thanks.